Hello everyone, good day. My name is Mark Redera Cervantes, 20 years old, and I am from BS Ed Science 1A. So today I was given a topic and I was assigned by our instructor to have a short discussion about the given topic, which is amides. So without a further ado, let's get started. So what is amides? So amides are derived from carboxylic acids. A carboxylic acids contains the COOH group, and an amide, the OH part of that group, is replaced by an NH2 group. So primary amides are named by changing the name of the acid by dropping the OIC acid or the IC acid endings and adding amide. So you can look at the figure below. Secondary amides are named by using an uppercase N to designate that the alkyl group is on the nitrogen atom, no? While tertiary amides are named in the same way. So just look at the figure below for the secondary and tertiary amides. Okay, let's move forward to the preparations of amides. So in preparation of amides, there are two ways. First is the carboxylic acids, and second is the acid chlorides. Okay, let's discuss first the first preparation of amides, which is the carboxylic acids. So the carboxylic acid is first converted into an ammonium salt, which then produces an amide on heating. No, it produces daw when heating. The ammonium salt is formed by adding solid ammonium carbonate to an excess of the acid. So for example, ammonium ethanoate is made by adding ammonium carbonate to an excess of ethanoic acid. So 2C3COOH plus NH4 2CO3 is equal to 2CH3COONH4 plus H2O plus CO2. So when the reaction is complete, the mixture is heated and the ammonium salt dehydrates, producing ethanamide. So CH3COONH4 is equal to CH3CONH2 plus H2O. So that was the preparation of amides when we talk about carboxylic acid. Okay, let's proceed with the next preparation of amides, which is acid chlorides. So in the first stage, the ammonia reacts with the ethanol chloride to give ethanamide and hydrogen. So then the hydrogen chloride produced reacts with excess ammonia to give ammonium chloride. And you can combine both equations to give one overall equation. So for further information, you can utilize your phone so you can search it online and make sure that you have a guaranteed or legit source, okay? Okay, let's hop on to the reactions of amides. First, we have hydrolysis followed with nitrous acid, then reduction. Fourth, Hofmann degradation, and fifth is dehydration. So let's tagsa-tagsa them all. Let's separate them all so to better understand. Let's start with hydrolysis. Acidic, used concentrated acid, HCl Al2SO4. So products, ammonium or ammonium salt and carboxylic acid. Like for example, CH3CO NH2 plus H2O plus HCl. No, that was equal to the product CH3COOH plus NH4 plus Cl negative. So here is the general equation for hydrolysis acidic. Just take a look at it and try to remember that one, and also try to understand, no? Since we are just using internet, and I know that all of us has difficulties when it comes to it. So you can search in online also for additional information. Let's proceed with hydrolysis alkaline. So use concentrated sodium hydroxide solution. So products, ammonia or an amine and carboxylate salt. So example, CH3 CnH2 plus NaOH is equal to CH3ZOONA plus NH3. So that was the hydrolysis alkaline, and it is quite different to hydrolysis acidic, no? And here is the general equation of hydrolysis alkaline. So take an observation and then try to understand, no? You can also utilize your phones, just search it on the internet for better understanding and for more information. Let's move forward with the reaction of amides number 2 with nitrous acid. So amides reacts with a nitrous acid or HNO2 to give carboxylic acid and N2 gas. Nitrous acid or in HNO2 is unstable and is prepared in situ by the reaction of dilute HCl or dilute H2SO4 with sodium nitrate in the absence of heat. NaNO2S plus HClAq to NaClAq plus O is equal to NOHAQ or nitrous acid. RCONH2 plus NaHNO2 to RCOOH plus N2 evolved to H2O. And here is the general equation of reaction of amides with nitrous acid. Just take a look at it. Let's proceed with the third reaction, which is the reduction. So amides RCO and R2 can be reduced to the amine RCH2 and R2 by conversion of the C is equal to O to CH2. So amides can be reduced by LiAIH but not the less reactive NaBH4. So why is that so? So the reason is this. Just take a look at it. Look at the N substituent in the following examples. I will no longer read this one, just read it yourself, no? Let's then proceed to Hofmann degradation. So Hofmann degradation is a reaction between an amide and a mixture of bromine and sodium hydroxide solution. So here, heat is needed. The net effect of the reaction is a loss of the CO part of the amide group. You got a primary amine with one less carbon atom than the original amide had. The general equation will be RCONH2 Br2 over NaOH is equal to RnH2. So that was the general equation of Hofmann degradation, no? And it is said that heat is needed. Like for example, in Hofmann degradation, ethanamide to methylamine. Full equation for the reaction is CH3CONH2 plus Br2 plus 4NaOH2 CH3NH2 plus Na2CO3 plus 2NaBr plus 2H2O. So the Hofmann degradation is used as a way of cutting a single carbon atom from out of a chain. Let's hop on to the last one, dehydration. So amides are dehydrated by heating a solid mixture of the amide and phosphorus 5 oxide 3 P4O10 slash phosphorus oxychloride POCl3. Water is removed from the amide group to leave a nitrile group. Cn, the liquid nitrile, is collected by the simple distillation. For example, with the ethanamide, you will get ethanitrile. So CH3CONH2 to PO4O10 over H2O is equal to CH3CN. So that was the hydration of reaction of amides, and that is the last one. So that ends with the reactions of amides. And now let's proceed with the next topic, no? The chemical properties of amides. So amides are the least reactive of all the acid derivatives toward nucleophilic acyl substitution reactions. Amides are much less basic than amines. Amides behave both as weak bases as well as weak acids. Amides can be hydrolyzed by boiling with water, acids, or alkalis. So that was the chemical properties of the said amides. While its physical properties are formamide is a liquid while all the other amides are colorless, crystalline at room temperature. So the lower aliphatic amide are quite soluble in water. The solubility decreases with the increase in size of alkyl groups, and the melting and boiling points of amides are higher than expected. So it has a higher boiling point. So question, do amides have high boiling points? Of all acid derivatives, amides have the highest boiling points. This is not only due to the dipole-dipole interaction, primarily and secondary amides also experience hydrogen bonding. So that's why it has the highest boiling point. With the exception of formamide, HCO and H2, which is a liquid, all simple amides are solids. Primary and secondary amides can have hydrogen bonding and therefore have high boiling points and melting points. Tertiary amides cannot hydrogen bond, so their boiling points are lower than those of similar size amides. Primary, secondary, and tertiary amines can hydrogen bond with water, so with the lower members of the series are soluble in water, with borderline solubility occurring in those that have 5 or 6 carbon atoms. Like the esters, solutions of amides in water usually are neutral, neither acidic nor basic. So I've prepared here some examples. So name formamide, melting point 2 degrees, boiling point 190 degrees, solubility in water, soluble. So next, acetamide condensed structure CH3CONH2. So melting point is 82 degrees, boiling point 222 degrees, and it is soluble. Next in line we have propionamide, which has condensed structure CH3CH2CO and H2. Melting point 81 degrees, boiling point 213 degrees, and it is soluble in water. Next, butyramide, condensed structure CH3CH2, CH2CO, and H2. So melting point 115 degrees, boiling point 216 degrees, and it is soluble in water. Lastly, benzamide, condensed structure C8H5CO and H2. Melting point 132 degrees, boiling point 290 degrees, and it is slightly soluble in water. Slightly lang siya, unlike sa other examples. And another additional information, the amides generally have high boiling points and melting points. These characteristics and their solubility in water result from the polar nature of the amide group and hydrogen bonding. And again, primary and secondary amides can have hydrogen bonding and therefore have high boiling points and melting points. Tertiary amides cannot hydrogen bond, so their boiling points are lower than those of similar size amides. And again, what is amide? So amide is a functional group containing a carbonyl group linked to a nitrogen atom or any compound containing the amide functional group. Amides are derived from carboxylic acid in an amine. Amide is also the name for the inorganic anion NH2. It is the conjugate base of ammonia, NH3. So there are some key takeaways so you won't forget what is an amide, no? An amide is an organic functional group with a carbonyl bonded with a nitrogen or any compound containing this functional group. Example of amides include nylon, paracetamol, and dimethylformamide. The simplest amides are derivatives of ammonia. In general, amides are very weak bases, so that is amides. So examples of amides include carbosamides, sulfonamides, and phosphoramides. Nylon is a polyamides. Several drugs are amides including LCD, penicillin, and paracetamol. Uses of amides. So amides may be used to form resilient structural materials. Example, nylon and Kevlar. Dimethylformamide is an important organic solvent. Plants produce amides for a variety of functions. Amides are found in many drugs such as paracetamol. So that is amides, no? All our topic talks about amides and the importance of amides in our daily lives. And I think that ends my discussion for this day. Thank you so much for listening, guys, and I hope you learned something about my discussion. Thank you and bye bye. Stay safe, everyone.